Okay. And we are live. Welcome to today's mob, guys. Today I'm taking you through the mob today. Okay. So we should start from resolving instance variables through self. Yeah, I remember the last statement Sigu said was the self at the end, or let me say the self owns the instance variables. As self changes, the self owns, or it has a way of owning the instance variables. Okay, so in this case, we'll see how the relationship between maybe how instance variable change and work as also self changes. So, simple rule governs instance variable and their resolution. Every instance variable you'll ever see in a Ruby program belongs to whatever object is the current object, which is self. So we have an example here. We have a class C. We have a method showVar. We are defining an instance variable there. We are initializing. Then here we are printing it out. Then we have this instance variable here. So notice at this point, what is self here getting at this point? Todd.
At that point, self is any instance of C that's going to call the method showVar.
Okay, yeah. So at this point, the self is an instance of C. At this point, now we are outside the method definition. At this point, self is C. So we are now creating an instance out of C and calling show var method. So I think I can. So what? So I have a class. Let me say class account. Let me say balance. Then I have amount. Huh? Then I have again. Oh, I have not printed it out. Yeah. What am I typing? Okay, amount. Yeah, ndio alikuwa anasema. Edit. So notice this point, the return is 50 because it's returning. Why do you think it's returning 50? Last executable. If it's in the class definition, if you have initialized in even inside a method. So you're saying if I do, let me just reopen it, then.
If you have a class, methods inside it,
Mhm.
It will return the last value
Mhm.
as its return value. If you assign a value to a variable, it always returns the value that was assigned. Or if you define a method, it will return a method.
Yeah. Oh, yeah.
What if you define a method, then an assignment, then a method?
Then an assignment, then a method. It will return the method. The last line of the class definition.
So, which in this case is our initializing the amount, so it returns 50. Oh, but my main aim was to have class account. Then in the, let me just call it val. This is another, then at amount. And then again amount. Oh. So if we create an instance of the account class, then call val on it. In this case, we'll get 1,000. Yeah.
How do you get 145?
So, there is no, you want that new. Yeah, it, yeah.
So I'll tell you the printed that
Printed.
puts amount equal 145.
Puts amount equal 145. Or than just.
Yeah, then just give it.
The account that new and display.
If we do.
Because it's not total. And whenever you do an instance, it returns the instance. That's right. It always returns the instance. You have to verify it.
Man.
And what if you just do at amount?
I think let me just know that we have them, yeah? Oh no. Yeah, put S amount. Then I close it. If I do a account dot new. Account dot new. I'm not expecting it to print. Oh, this way it will print.
I'm not sure that it will print. I'll take a guess.
What's your theory of saying it's going to print it?
When you instantiate, it's I think it goes through other than the initialize method, which is normally called. It might call any class level. I'm not sure that it will call the class called anything on the class level. I'm not sure that it will call.
I'm thinking since we've declared an instance variable inside the class, then it can be accessed outside the class.
An instance variable.
Outside? You're saying outside the class?
Or,
Outside.
yeah, because I'm thinking how we refer to, like in Rails, how we use an instance that's been defined inside a class. Inside, in the views or
There's a hack that Rails uses to do that.
oh, it's not. And what if this was a constant? Could we access it outside the class?
Yes.
Glow. Yeah, magic. Oh. Instance. Didn't print out anything, return the instance.
So there's no way to. At amount won't work.
We are outside. It's not a global variable. This way. Nil. At something. Why is it returning nil?
Instance variables are never
Interesting.
You can do at people, just do it.
You can do it.
Never. It's always.
Okay. Awesome.
And how are global variables declared?
It's the next place. Dollar. Eh? You were saying triple.
What's triple at?
Oh. Is it triple or double? It's
Double is a class.
triple. I've not worked with this.
I'm not really sure.
But I'm sure if you want, yeah.
You can try the triple at.
So okay, maybe if I have a class, I have triple at.
Waiting for a close.
Is it really? Oh, yeah, it's waiting. What is it waiting?
Because of the extra at.
Yeah. Oh, we did not conclude on this. So is it treating us? This is only available for. It is not.
This only works with loading profile. That's when they get around.
Anything else after that we can text you.
Yes, it's like you can't do anything.
Okay. I think we have talked about this. Okay, they're saying the trap is that you might think it will print instance variable can appear anywhere. I did not think it can print this. Yeah, the code prints. It prints what it does because the at v in the method definition and the instance variable v outside are completely unrelated to each other. They are both instance variables, both named at v, but they are in the same variable. They belong to different objects.
So the second one belongs to C. The first one belongs to
Instance of C, yeah. The first lies.
idea. So I think create a a class method of C.
Create a class method of C, then put at V inside it. Okay, create class C.
I've exited. Man.
Create a class C.
Define an instance method.
Instance.
Yes.
Okay.
Then puts
Let me have my name. Puts. Okay, let's say that.
and define a class method called servant.
Okay. So gedit. So we have a class C. And
Name.
here.
Yes. Then just above that, you can do at name equals.
This one.
Okay, yeah, and before the class definition, before the method definition, right there, add at name equal class name.
Equals?
I am outside.
Oh.
Okay, then define a class method.
Oh, the name one. A different one.
Self dot class name. No. You?
Dot editing.
Yeah, just do anything.
Okay, maybe my eyes.
The first one needs to have a my underscore name.
Yeah.
The first one. The first class definition. The first instance method definition. Call it my name.
Oh, I remember.
The problems we had. Okay, then inside my edge puts at name. Okay, run that.
This will return my age.
This will return I'm outside. Huh?
Now, if you paste it immediately,
It will return
I think it is
which is I am outside.
no, it will return the method my age. The
Oh,
moment you paste it, I have it. That's my age.
mm, output of this. The last it will only print it out when we call it. So it should return the method. Last method, yeah.
That's my guess. So let's call check out this. I am outside.
I am outside. Yeah.
Instance. Okay. Let's make it better. Go back to the edit. Then change.
Remove
Remove
this.
that.
Yes. Oh, didn't. So this nail. Did my oh yeah, I'm out. Yeah, I'm outside.
That will return me. It's nothing and return.
Yeah. Nail. What is it?
What
Oh.
happens when you put nail? When you put nail, it's nail.
That one. Like empty or something.
So because at nail is nail, it will return.
Interesting. Okay, so yeah, first V lies inside the definition block of an instance method of C. Then that fact has implications not for a single object, but for instances of C in general. Each instance of C that calls this method will have its own instance variable at V.
Each instance has its own.
Yeah. The second belongs to the class object C. So this is one of the many occasions where it pays to remember that classes are objects. Any object may have its own instance variable, which is its own private stash of information and object state. Class objects enjoy this privilege as much as any other object. Yeah, they're just expounding on the ownership. The logic required to figure out what object owns a given instance variable is simple and consistent. Every instance variable belongs to whatever object is playing the role of self at the moment the code containing the instance variable is executed. So if we create an instance, call that method self at that moment being the instance of the class. So at that point, the owner of the instance variable is that instance of that class. Okay, let's see. Here now we have, this is now different a bit. We have, here we have to put a string, print self at this point, which is C. Yeah. Then initialize this instance variable here. Then we print this string, then we print the instance variable, this string. So at this point, self is still C. Then now we enter the method definition. We print that. Then here self is now the instance of C. Yeah? Then print out that, yeah, belonging to self. Okay. Then print again instance variable. So if we look at just as you have said, at this point, our instance variable or what we will print at this point is because assuming now we still don't have this. At this point, this instance variable belongs to C. All the self is C. And we are printing, we are printing it in when whoever the self is at this point, we want the value of this instance variable. So it will print this one here. Yeah? Then now we have that then we are printing out this. Eh? Eh? Oh, actually, we have talked. We have talked about this. Are any questions? Okay. So, what is scope? Refers to the reach or visibility of identifiers, specifically variables and constants. So different types of identifiers have different scoping rules. So if you have an identifier X for a local variable, in each of two method definition, it has a different effect than using a global variable X in the same two places, because local and global variables differ as to scope. They differ. Okay, the main difference is in the scope they cover, or their main difference comes as a result of the scope in which they are visible. Yeah, so in this section, we look at the three types of variable, which is global, local, and class variables. Yeah, self and scope are similar in that they both change over course of a program, and in that you can deduce what's going on with them by reading the program as well as running it.
There's a point you've left out.
Mhm.
The one in brackets. As you've seen, instance variables are self-bound rather than scope. What does that mean?
They are owned by the whoever self is at that time. Yeah.
They cannot go outside.
So, but scope and self aren't the same thing. You can start a new local scope without self changing, but sometimes scope and self change together. You can start a new local scope without changing the self. So, what instance can that be? Assuming you have, maybe if you have an instance variable in a class, then maybe define a class object, a class method, and then you also have an instance variable inside that. We haven't, is it a new scope? It's not a new scope.
I'm also trying to figure out how that happens.
A new local scope without self-changing.
I think, see, methods are scopes.
Mhm.
So I think when moving from an instance method to another instance method, we're changing scopes, but we're not changing the self. The self is just
How are you moving from an instance method to an instance method?
changing scopes. Like an instance method could be like name, then we have def age. Both of them respond to,
Oh, I think I've gotten. So it's like if we have a new local scope can be, maybe we have instance methods, for example. If we have instance methods, we are,
As long as self is still the same, the instance method is not changed. But the local variables might change. If you call name, then if you had a variable called name inside name of the name instance method, then it might be get. If you go to age, it is not the same name as the previous.
Yeah, but sometimes scope and self change together. So that can be an instance where scope changes, self also changes. If you create, at that point self has changed, then maybe in that instance, maybe you create maybe like a singleton method, maybe. Scope has changed, self has changed.
For a singleton method, I think the scope is the same.
If I create an no, that's not an scope and self changing. If you create an instance, self has changed, and the scope is still an instance of. If it's an assuming we have which one? Assuming we have an instance method. Assuming we have an instance method. So if we create an instance of the class, then call the instance method. At that point, has the scope changed?
It's still valid within the instance.
It's still valid within the instance, but self has changed.
Self changes are different.
Oh, self hasn't changed because we are calling it on an instance. So the moment we call, now I think I'm getting it. If we create different instances and call an instance method on them, both the self and the scope, because every instance variable has its own self. So if you create instances and call an instance method, the self is changing. Then now let's look at scope.
If we're calling the method on the same object, on the same instance, the self is still the same.
If we are calling
the method, no. If we're calling the same method on different instances, the scope is the same, but the selves are different.
Not the scope.
How is the scope the same?
I'm referring to
The scope is different.
Oh, because it's an instance of the class. So
I think we might get an answer if we focus this.
of where how
How both
scope
change.
both change. Okay.
Yes, the moment you get more explanation.
Okay. So they have in common the fact that they are both necessary. Okay. So let's start at global scope and global variables. So a global scope is the scope that covers the entire program. That is like maybe in your system, things like Ruby version, Ruby. You can usually check for those anywhere, no matter where you are.
Those are global.
Those are they? Oh, are those constants or variables?
Actually, they're constant.
But they are
But actually, they are more.
constant is a constant variable.
Constant is a global variable.
Though
They
I
have the same. No.
though with a constant is not global. Actually,
It doesn't have
a constant doesn't have to be global. Actually, constants have scope. Can have, let me say. But a global, so I think they are not constants, or it's a mixture of constants and. Can we say a constant? No, it's not. A constant is not a global variable.
But They could share the
It's not, because
can be,
it.
but it's not.
Yeah.
same property at some point.
At it can be a global variable.
Yes.
Yeah. It can be. Yeah. So, global scope is enjoyed by the global variables, which are usually initialized, or when we have, and we initialize it by adding the $sign just before it. They are available everywhere. They walk through walls. So if you start a new class or method definition, even if the identity of self changes, the global variables you've initialized are still available. Yeah, we think after that we can do a. Okay, let me go to gedit first. Do away with this. So let's have. Assuming it's, I'll call it my private key. Oh no. Then after this, now I have my class. Okay. Call it account. Then I have a method. Let me call it login. Save. Put this. A private key. Populate that, then
But you need the color and referring to that.
now that's what I want to see. If
It's like an instance
if it's a global, yeah. Got it. Then end. Copy that. So if we create an instance of account and then call login on it, it should display our private key, which we defined outside the class. Yeah.
So that means if we have the global, it will also be available to the instance. No, not the instance, the class.
Class method of. Yeah. So if we define, let me define a class method of account. Let me just say register, then put as private key. And then call it so it's available everywhere. Yeah. It's omnipresent. Yeah. Okay. So here they have an example initializing the global variable, then they are now calling it or accessing it in the instance method of C. Okay. You'll be told by this in no answer the term global. Okay. If you change all occurrences of G that to a non-global variable. If you change all occurrences of this or to a non-global variable such as the local variable, you'll see that the top level isn't. So in short, they're saying, oh, if we change this to something else, no. Let me repeat that again. If you change all occurrences or all occurrences of this to a non-global variable. So maybe I change all occurrences mean wherever I'll be using this, I change it to, yeah. So, yeah, actually, so, yeah, what will happen if I do that? Yeah. That, so at this point, if we create an instance of them, for the account class, yeah. Okay, so that's basically about that. So we have built-in global variables. So the Ruby interpreter starts a fairly large number of global variables already initialized. Yeah, so they are global variables, not constants. These variables store information that's of potential use anywhere and everywhere in your program. So, for example, the global variable, this contains the name of the startup file for the currently running program. So now that, I go outside $0. Oh, so this is, we're accessing a global variable. So this shows you the startup file, which in our case it's the current running program. Then we have this dot content startup file, yeah. The $0. Then we have a dollar colon that contains the directories that make up the path Ruby searches when you load an external file. That's a dollar colon. Yeah, so this where Ruby searches for its instance. Oh, this is the only Nini. Yeah. Then we have now $, contains the process ID of the Ruby process. And there are more. So process ID.
Let's search for Ruby. Processes. Process ID.
Yeah, 96. Yeah. Which is what we were getting. Yeah, okay. What happened?
So what happens if you kill? I don't think you can kill. Yeah, I think you can.
I think which process is this? Is it the
No, instead of doing like that.
maybe? Oh, this is the pride that's taking this
Yes,
process.
it's the pride that starts out that process.
So
So I just wanted a way of
killing and seeing if that will change or the output of
now. Of course, if you keep it like this, it will die.
but I mean it will even exit the
Yes, it will die.
yeah.
But I wanted a way of killing this.
uh,
But I don't think
it is a yeah.
see what
But, are you sure? So probably if we go here, yeah, it has exited. Then if it starts, it should.
to check another separate PID.
Oh, it hasn't.
Just go and dollar.
We have to do something. Yeah,
Now it's 9.
15. Okay. What happened? How did I reach here? How did I reach here? We win. Yeah, so this place basically is about talking of the global variable. So let's look at the pros and cons of global variables. Oh, this section, if I remember, mainly they were trying to say that Ruby is object oriented. So if you're in Ruby, you try to retrieve and maybe transform data through objects. But the moment you have global variables, you're making it available to like all the entire objects that you'll ever create. Your global variables will be available to them. But you are doing object-oriented mainly. You are creating an object such that you may retrieve particular information, and you don't want to make accessible things that maybe you did not plan it to have and stuff.
So it's probable that it might be changed by some other method. Is it possible
to change a global variable? Or that you initially, okay, I don't know about that. But there has to be a way. But how will you know that you initialize some global variable somewhere? Assuming, I mean, just in it's a new project. Maybe we're collaborating. Somebody had his or her global variables defined somewhere, but I don't know about them. How will you know about them? Such that maybe, so you have to know about them to reset them and stuff maybe. But if you reset, oh, that's interesting. Can you reset a global variable in your local scope?
Reset. I think you can.
Yeah, such that you use now the value of. So it's like let me have a class. Okay, let me have a global variable. Let me call it G. Then Here we have get URL. Then we have a class getty. But now inside here we have g equal to whatever that is. Then an output is g. Yeah. This is what. Yeah, this one. So if we create an instance of getty and call my name on it. Raw.
Yes.
Yeah.
So how about right now? If you look for it, will it be oral or it will be?
Oh, it will be get your oh, just like this. This way now I think scope wise. Yeah. Yeah, I think it only did that for this scope.
But the scope of the variable is global.
It's global, yeah. But I just wanted to change it. The moment I change it here, it's not. I'm not changing it globally.
It's not a local variable. You access it locally, but it's available globally.
Only one way to find out.
Boom. What Sigu is saying is, in case you have this, then I have my number there. Then I end and still access my num here. We have defined a global variable, so change. Oh, so in short, changing it here is like changing it outside. Yeah. Okay. Thanks, guys. I think we'll stop there for today, and we will. Oh, where am I? Was I really here? Yeah, I think we'll start from the pros and cons of global variables next time. And now let me catch up on the Ligza mob. Adios, guys.